As an example of working with XML, we're going to start with RSS feeds. RSS stands for Really Simple Syndication, and it's an XML format for storing information about content on a website that changes frequently. The basic idea is that instead of going to a website to see what's new, you can have software inform you when something on the website has changed, and it can tell you what has changed. As our example, we're going to use an RSS feed from the New York Times. So the New York Times has feeds for topics that are covered frequently in the news. And I made a copy of their RSS feed for the Cuban Missile Crisis on in my GitHub account so that we could use it to explore the feed without worrying about how the feed changes over time. So here's a link to the actual topic page where the updated information is, and here's a link to my copy, which was archived in 2018. Now, if we import the elements for this XML file, it tells us that we can have it as a notebook object, or symbolic XML. Now, if we just want to read the feed the way that we would in a newsfeed reader, we can open it as a Mathematica document with the create document command. So let's see what that looks like. So here is our RSS feed, and each one of these things is a news story, and this was refreshed just now, but the actual data comes from 2018, as I said, because I archived it. If we don't want to read it in a browser or a feed reader, we can instead import it as a text and get a string that we can explore. So I'm going to import this as text and put it in this symbol, RSS source. We can test it to see what it is. It's a string. And we can take the first 400 characters just to see what it looks like. And when we do that, we can see the tags tells us that it's RSS version 2. This TTL usually means time to life. That's how fresh this is in some sense. And then here's the title, Cuban Missile Crisis. Here's the end title tag, so matching open title, end title tags, Cuban Missile Crisis 1962. That's the title of the feed. Okay, now if we want to know what elements in the file are titles, we can use the string cases command. So we're going to give it a source file. We're going to ask for the shortest thing that is enclosed in open title and end title, and then we're going to return just that thing. And that gives us Cuban Missile Crisis. This is marked up as a title. But this next one, we'll see Trump says on North Korea and Iran and NAFTA and so on. That's the first title here. That's also marked up as a title. So there's the title of the feed itself, and then there's the title of the individual news stories. Now, this approach, where we just look for something that matches a pattern on either side of the string of interest, doesn't require that our commands know anything in particular about XML. These could be any strings at all. If this was marked up in a passage of Klingon language, it could recognize that just as easily as it recognizes XML tags. So this is what we mean by scraping. We're using simple low-level pattern matching to isolate some information on a page, and then we're trying to grab just that information of interest while leaving the rest of the stuff behind. Now, if we want a representation of XML that incorporates a higher level understanding of markup, we're going to import not as raw text, but in the form of symbolic XML. So I'm just going to evaluate this and show you what it looks like, and then we can go back and look in a little more detail about what's happening. So in symbolic XML, what happens is an XML expression, which looks like this: opening tag, closing tag, data in the middle. Tags can have what are called attributes, so this part, attribute equals value, can be part of the tag. This whole expression gets converted into this matching symbolic XML expression. The tag name ends up here, the attribute name ends up here, the attribute value ends up here, and then the data that's inside the tag ends up here. And so here, let me just highlight an example. Well, here's a fairly simple one. This XML element right here the name of the tag is TTL, and the data inside the tag is 60, and then we saw that in a few seconds ago in the raw XML. Now that the XML is in this symbolic form, we can extract information from it by matching XML elements rather than by matching just strings. So if we're looking for titles, we use a cases command. We're looking inside our symbolic version now. We're looking for an XML element where the tag is title and the other two things can be anything. And Infinity says match this pattern as at every level of nesting. And here's our first one, Cuban Missile Crisis, and here's our next one. We'll see Trump says on North Korea, and so on and so forth. So we can extract the exact same information, but now we're doing so by knowing what XML elements are being used in a particular context. If we just want the titles, we can modify our command slightly to get the list of titles, like that. Now in this file, the item tag, which we haven't looked at yet, serves as a record, and it contains a number of fields. So if we want to return the first item, we're going to search for an XML element that's tagged item, like this. And this is the whole item tag for the first story. So it's got all of the information. It's got the title for the story, it's got a link to the website, it's got the description, it's got the author of the article, and so on. So by knowing how the XML is structured, we can actually extract information in a more structured way. The third part of that sample record we just looked at is the list of fields. And if we use the replace all command, we can extract tag and data like this. So here's the title, links to this, the link links to this, description links to this, and so on. We can then, if we can extract a single record, once we've parsed a single record, broken it down into its pieces, we can extract all of the records using the exact same formatting and put them into a data set, which is what the next command does. So now we have a data set of news titles, of links to the stories, of the descriptions, of the authors, and the publication dates. And we can wrap this up in a function that will parse the news into a data set. Now, we've been working with this stored RSS feed from 2018, but the next step would be to take our tool that we use for parsing RSS and use it to parse the live feed. So what's happening in, as I'm writing this, August 2020. Let's try this. So here's the stories for today that the New York Times has classified as being in some way related to the Cuban Missile Crisis. Here's the titles, here's the links, description, and author. Now that we've done the work so far, we can also use the information to do other things. So for example, we could take the locations from today's stories. There are 3 of them that have locations listed, and we could use a geolist plot to see those plotted on a map. We see the United States and Russia and so on.